All right, so we're going to talk about section 10.8. That's unit 10, section 8. And we're going to cover secants and how they interact with circles and the central angles of circles. And they're pretty straightforward and similar to how they've acted before with intersecting chords and inscribed angles. So we're going to call this angle, or this circle C, right? And say that we have circle C, and it's intersected by two secants. So secant, if you may remember, is a line that comes in here, and it will have a pink line or a burgundy line, and it comes in here, and it goes this way, and it intersects a circle, making, this, remember, is a chord, is the part of the secant that is within the circle. We'll have this line right here, goes in there, and then we have another line. We'll say it goes like this. We'll say it's like this. This blue line comes in like this. Again, makes another chord. But these are the two secants. We'll call it secant blue and secant burgundy. All right, and they intersect at this point black. Point black right there. We'll call it point B. And we'll call this point A, and we'll call this point Z, because why not? All right, and we'll call this point X and point Y. All right, so an interesting relationship happens. Well, I guess first we'll identify some more things. We'll identify this arc here. Let me get some colors. We'll call the far arc on the opposite side of where the secant, the small secant, or the small arc. We'll call the big arc formed by these secants, the red secant, or arc XY. And we'll call the orange arc AZ here. We'll call that an orange arc. Okay, so we have arc AZ, and we have arc XY. Is also the big arc. And of course, like the arc measure of XY will be bigger than the arc measure of AZ, right? But is there a relationship? Well, of course there's a relationship between those two and the measure and this angle measure. We'll call that, of course, measure of angle ABZ. ABZ, and of course you have its vertical angle there. All right, so what is that relationship? Well, there is a theorem called the exterior secant angle theorem, and it says the measure of an angle formed by two secants intersecting in the exterior of a circle is 1/2 the difference of the measure of the intercepted angles. Well, that's a lot of words. What that means is that this measure angle, I'm going to call this Y, and I already used Y. I'm going to use a Greek letter. Let's see. I usually use psi for this angle. For my intercepted angle, I usually use. I've been using other angles. What am I going to use? I'll use. Hold on, let me think of a cool letter to use. I'm going to use uppercase gamma. It looks like a psi, like a reaper psi. That's uppercase gamma. That's pretty cool. This uppercase gamma looks like a reaper psi. Anyway, lowercase gamma looks like this. It's like a little zoomy. But anyway, we're going to use an uppercase gamma. So uppercase gamma, also known as the measure of angle ABZ, uppercase gamma is going to be equal, looks like a big R, uppercase gamma equals, make it look even more sinister. Okay, uppercase gamma is going to be equal to, when equal to the arc measure of x, y, the bigger one, the one farthest away, the bigger arc measure, minus the smaller arc measure, the orange one in my example, divided by, you guessed it, 2. Divided by 2. Okay, so zoom out a little, and we'll do a little example here. Okay, I'm just going to make up some values, and we'll zoom out a little more. That probably works. Not quite. We'll do ups and downs. That might work better. Okay, so we have. Of course, I've recognized the relationship over here. Vertical angles are congruent. Linear pair, you guessed it, or you remember, are supplementary. So they might get tricky and give you this angle, and you got to figure out this, given that angle as well. You have to do some algebraic gymnastics and solve for this, in which case, I'll use a different color just to show the math for this one. I don't have a different color right now. Okay, so in order to do that, you multiply both sides by 2. So it'd be 2 times uppercase gamma, okay, equals, and then if we were solving for the xy, we would have to add a z to it. We would have to add a z to it, a z arc measure, and then that would then equal our xy arc measure. All right, so that's like how you do that in this instance. Okay, so anyway. So I guess, there's going to be, I'm going to hold back on the example. I guess I'll just write it on here. I'm not going to hold back, I'm going to write it on here. So say, for instance, this was, let's see, that looks like a good, we'll say 97 degrees, okay? And this is 25 degrees. Should be orange. This is orange. This is 25 degrees. 25 degrees. Then the measure of our outside secant intersection angle, our uppercase gamma, would simply be this number of our bigger arc measure minus the number of our smaller arc measure divided by 2. All right, so it would be 97 plus 25 divided by 2, and that would be, this measure would be 61 degrees. 61 degrees, 61 degrees, meaning that this would be 61 minus 180. This one would be 119 degrees. So that's how that whole thing would kind of come together. Okay. Hope this helps out. It's pretty straightforward. And if you have any questions, let me know. Algebraically rearranging this stuff. So to understand the relationship is what is the most important. One thing that people often make mistakes in is they may give you, or they will be giving you, algebraic expressions. Say, for instance, here, maybe this one is like a 3x minus 2, okay? Well, when you plug that into an equation, right, put that within parentheses, right, when you're building your equations, because it's going to have a minus sign in front of it, right? That's going to make this negative, and then that would therefore make this positive, okay, when you dissolve that set of parentheses, okay? That's a big mistake that a lot of people have the potential to make, right? And that'll change your answer when you're doing your algebraic gymnastics there, okay? So don't forget to do that, okay? So when you're building your equation like that, okay? I recommend that you do all your algebra, generically, in generic terms, right? And then plug in the values. It seems to be a lot easier, less prone to mistakes when you do that, okay? I hope you guys, like I said, have an easier time with this, and if you have any questions, let me know.